Questions 21 through 25 on the 2019 Grade 9 Pascal Math Contest. What is the units ones digit of the integer equal to 5 to the power of 2019 minus 3 to the power of 2019? Well, let's talk about the units digit of powers of 5. 5 to the power of 1, 5 to the power of 2, 5 to the power of 3, and so on. This is 5, this is 25, this is 125, and so on. So the units digit of any power of 5 is actually always 5. So if we look at 5 to the power of 2019, that's going to have a units digit of 5. Okay, well that's pretty straightforward. Now let's look at the units digits of powers of 3. 3 to the power of 1, 3 to the power of 2, and so on. Let's see what happens. Well, we will hopefully either see a pattern or see something that's the same. 3 to the power of 3, 3 to the power of 1 is 3, power of 2 is 9, power of 3 is 27, power of 4 is 81. So it goes 3, 9, 7, 1. And if you do the next few, you will also get 3, 9, 7, 1 as the units digits. So it repeats like that. So basically, if we want 3 to the power of 2019, we have to extrapolate that list. So it looks like every time there's a multiple of 4, the units digit is 1. Okay, so if I go all the way up to 3 to the power of 2019, I'm going to have to get some sort of a idea of where I am in this 3, 9, 7, 1 pattern. Well, 2019 is not divisible by 4, but 2016 is. So that's going to have a units digit of 1. So 2017, 2018, 2019, 2020. All I have to do is just use the pattern now. The pattern is 3, 9, 7, 1. So 3, 9, 7, and then 1 again. So the units digit of 3 to the power of 2019 is 7. So that's going to be basically like this. So all we have to do is really just look at the units digits. 5 minus 7 is negative 2. Okay, well, that's a little bit of a problem because none of these are negative 2. And you can't have a digit of negative 2. So you got to think about this. And the simplest way to illustrate what that really means is just with an example. Let's say you have 5 to the power of 7 minus 3 to the power of 7. 5 to the power of 7, the full digit is, full number I should say, is 78125. 3 to the power of 7, the full number is 2187. Now the reason I chose these is because they have 5 and 7, just like how we have 5 and 7 up here. But if you look at the full numbers, it makes a little bit more sense when you get the actual full number when you do the subtraction. That is 75938. So that minus 2 really is taking it back from 0. So if you had 10 minus 2, it would be 8. So I hope that illustrates it a little bit better. Number 21, the answer is 8, which is E. The integer 2019, 2019 can be formed by placing two consecutive two-digit positive integers, 19 and 20, in decreasing order. What is the sum of all four-digit positive integers greater than 2019 that can be formed in this way? All four-digit positive integers. So we have to ensure that they're greater than 2019. And the two numbers I choose are consecutive, okay? So I guess I'm starting with 19, and then 20, and then 21, and then 22, and all the way up to the largest one, which is 99. So that means if I want integers greater than 2019, the very first one I'm going to start with is 20 and 21. So 20 and 21. This will be the very first one because the one right before it is 19 and 20. But here's the thing, I've got to put them in decreasing order. So I have to write them as 21 and 20 like that because the previous one would have been 2019. And we've got to figure out all of them that are greater than. Okay, so that's the pattern. So the next one would be 22, 21. and then 23, 22, 24, 23, and you guys get the idea, dot, dot, dot. And then all the way down to the very last few, which would be 98, 97, and then 99, 98 would be the last one. And now I have to figure out the sum. These are numbers, so this is 2120, and this next number is 2221. So I just put a little bit of space in between just because I wanted to illustrate that they're two separate two-digit numbers that you're combining to make into a four-digit number. So they want me to add up all of these guys. Okay, is there some quick way? Because manually would be very time-consuming, and we want something quick. And I'm wondering if the long way is any less requires any less time. Oh boy. Well, let's see. I think we can do this basically the way you've learned how to add since you're in kindergarten, probably. So let's just do it one column at a time. That column. It looks to me like you're going to be adding 1, 2, 3, 4, 5, 6, 7, 8, 9, right? For each of these tens, like so for the 20s, for the 30s, for the 40s, and so on. 1, 2, 3, 4, 5, 6, 7, 8, 9 is 45. And you get that for each of those 20s, 30s, 40s, 50s, 60s, 70s, 80s. So that is what? 7, right? 20s, 30s, 40s, 50s, 60s, 70s, 80s. But then the 90s only goes up to 98. So that's not going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to be 1, 2, 3, 4, 5, 6, 7, 8 only. So that is 36. So and that totals 351. All right. So the 1 goes here, and 35, you carry the 35. Now let's look at that column. This is a little bit different now. It looks like you have a whole bunch of 2s, and you're going from 20 to 29, so that's going to be 10. So 10 2s. Similarly, you'll have 10 3s, 10 4s, and so on. 10 5s, 10 6s, 10 7, 10 8. But when you get up to the 9s, you're not going all the way to 99. You're only going to 98. So you only have 9 9s. Because it's going to be 90 to 98. And there's only 9 of those. So then it'll be 9 times 9. So that is 350 plus 81. But please do not forget the carry. So we also have to add that 35 carry. And when you do, you get 466. So the 6 goes here, and you carry the 46. So I hope this is making sense. Now we got to add this column. All right, so this looks like that 1, 2, 3, 4 situation. And I think we're going all the way up to 9 for every single one, because this goes up to 99. So that makes it a little bit easier. So the 1, 2, 3, 4 situation basically means that since each 1 to 9 sum is 45, and we're going from 20s, 30s, 40s, 50s, 60s, 70s, 80s, 90s, there's 8 of those, so 8 times 45, and that is 360. And then don't forget the carry to add that, so we got to add that 46, and when you do, you get 406. Yeah, 406. So the 6 goes here, and we got to carry the 40. All right, we're almost done. Now we have to add this column. Let's see here. So this is one of those situations where you have 10 2s. I think this is one where we go 10 2s, 10 3s like that, right? Yeah. Aha, but this one you got to be careful. This is the one I think people might make a mistake on. Because you're not starting with 20. You're only starting with 21. So from 21 to 29, that's only 9 numbers. So there's only 9 2s. But the rest would be fine. For example, it would be 30 to 39, 40 to 49, all the way up to 90 to 99. So all of those will be fine. It'll be 10 times 3 plus 4 plus 5, all the way up till 9. So a little bit tricky there. Okay, so that looks like 18, and then All of these look like 42 times 10, so 420. So that is 438. And then, of course, do not forget to add the carry when you add the 40. And that becomes 478. So 478 goes here. So there we go. This is my number, even though there's a space there. 478661. 478661 is choice C for number 22. A path of length 14 consists of 7 unshaded stripes, each of length 1, alternating with 7 shaded stripes, each of length 1. A circular wheel of radius 2 is divided into 4 quarters, which are alternately shaded and unshaded. The wheel rolls at a constant speed along the path from the starting position shown. The wheel makes exactly 1 complete revolution. The percentage of time during which a shaded section of the wheel is touching a shaded part of the path is closest to. Well, the first thing I'll do is just draw that path. And we'll just draw a straight line like this. And I've got to cut that into 14 segments and then illustrate the ones that are shaded and unshaded. So I'll do that. And then now the parts that are shaded, as it shows in the diagram here, I'm going to put sort of a bold to kind of illustrate that that's a segment that is shaded like that. So hopefully that will be sufficient to illustrate the shaded parts. Okay, so now this wheel is going to roll along, right? And when the wheel rolls along, this part of the circumference is shaded, obviously, and so is this part. So we have to figure out the distance. The radius, they told me, is 2 for that wheel. So the radius is 2, therefore the diameter is 4. Circumference is equal to pi times the diameter. So circumference will be 4 times pi. But each quarter segment of that circle would have a circumference that is c over 4. So that's 4 pi over 4, which is just pi. Essentially what that means is the distance from there to there is pi. Okay, so let's start. When we are now putting that circle along this path, for the first pi, it will be the shaded part that's touching. So this is pi in terms of its length. So let's draw that in. And pi is what, 3.14, right? So I think it'll help if I label this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then also the full circle is 4 pi. So 4 pi is what? 3.14 times 4. So that is 12.56. So the whole circle, because we're only doing one revolution, goes up to 12.56. So that's approximately about here. So that's about as far as we need to go. Okay, so now let's draw in the path of the circle. So again, I'm going to just draw a line to represent the circle. And then each 3.14 we will talk about. So the first 3.14 goes till about here. And that is the shaded part. So that's shaded. The next 3.14 would be from here to here. And that's unshaded. So 3.14 plus 3.14, that's 6.28. So until we get to this, it's unshaded. So this is 3.14. This is 6.28. So from here to here is basically from here to here. And then the next part, which is there to there, that's shaded. So that's the next 3.14. So now we're going to go 3.14 plus 6.28, which is 9.42. So approximately here, 9.42. And that's shaded. So I got to shade that in. And then the last 3.14 is that part, which I guess is the final part until we get to here. which is 12.56. Okay, so now we have to figure out when are the shaded portions of the circumference of the circle, these guys, matching the shaded portions of the path. All right, well, it seems to happen here, right there. Let's make that obvious. Let's try to draw that in red. So right here, this is one place where both of those shaded regions are overlapping. And when does it happen? Oh, we got to be careful. It happens here also. Don't miss that one. And then this one's pretty obvious. It happens here. It happens here. And I think that's it. Okay, so now let's figure this out. That fraction obviously is going to have a numerator and a denominator. The denominator is the full distance from beginning to end, all the way from beginning to end, which is 12.56. Now, the fraction on top, we've got to add this, which looks like from 1 to 2, which is 1. We've got to add this, looks like from 3 to 3.14, so that's 0.14. We have to add this, which looks like from 7 to 8, which is just 1. And then finally, we have to add this, which is 9 to 9.42, which is 0.42. Okay, let's add this up. And when we do, we get 2.56 over 12.56. And when you do that math, you get approximately 0.2, which is 20%, approximately. So it is closest to 20%, and therefore the answer is A. If P, Q, R, and S are digits, how many of the 14-digit positive integers of the form 88663311 PQRS48 are divisible by 792? Well, if this is divisible by 792, then that means that this is divisible by 792. So I'll write that out. 88663311 PQRS48 is divisible by 792 when PQRS48 is divisible by 792. And the reason I'm confident about that is because if you chop this off, if you subtracted it, you just get this, right? And this is divisible by 792. Try it out in your calculator. So then if you're going to add this to it, what you're adding also has to be divisible by 792. So I hope that makes sense. And if it does, let's keep going. So now we really just need to concentrate on this guy right here. The largest possible number of that form would be if you had all 9s for P, Q, R, and S. And the smallest, of course, if you had all zeros, 0, 0, 0, 0, 4, 8. And these numbers all have to be divisible by 792. So if I take the largest one, 9999948, and divide by 792, I get sort of an idea of how much I have to multiply 792 by. And this is approximately equal to 1262.5. So 792 has to be divided or multiplied by some number from, I guess, 1 to 1262. So that means PQRS48 is going to be 792 multiplied by some number. And that number has to be anywhere from probably 1 to 1262. So that's my sort of my range. Okay, now that we've established that, let's move forward. What can we do here? Well, if I multiply 792 by n, then it's got to end in an 8, obviously. So that means that n has to end in either a 4 or a 9 units digit. Because try it out. If it ends in a 4, 4 times 2 is 8. This 2 right there. And that's 8. If it ends in a 9, 9 times 2 is 18. It would give me 8. So n has to end in 4 or a 9. So that means n is going to be of the form 10k plus 4 or n is going to be of the form 10k plus 9, because n is going to be most likely a number that involves some multiple of 10. Not necessarily, but it probably is. So these two forms, I'm confident, are what represent n. Okay, so let's start with each of these. Let's start with this one, and then we'll talk about that one. If n is equal to 10k plus 4, let's put it back into that equation. And we get 792 times 10k plus 4 is equal to, so multiply this out, 7920k plus 3168. Okay. Well, the tens digit has to be a 4. We talked about the units digit, but now the tens digit has to be a 4. So the tens digit of this has to be equal to 4. So that means that when you multiply this number by k, and then you add to it 3168, it's got to end up with a tens digit of 4. So that means that this 2, which is the tens digit in that number, multiplied by the k, plus this 6, which is the tens digit in that number, have to equal the tens digit in this number. So 2k plus 6 has to be 4. Oh, if that's the case, then k has to be, let's see here, 4, because 2 times 4 is 8. 8 plus 6 is 14. That would give me a tens digit of, it would give me a 4 as that last digit. Or k can be 9, because 2 times 9 is 18, and 18 plus 6 is 24. So that means k can be either 4 or 9, or anything with the 4 or 9 in its final digit. So 2, 4, 2, 9, and so on, ... And therefore n, since n is 10k plus 4, and if you put these values of k into this formula, you'll get the following: 44, 94, 144, 244, and so on, ... all the way until the very end, 1144, 1194, and then 1244. And we stop there because remember, n is less than 1262. So now we're going to do the exact same thing, but this time with 10k plus 9. So 792 times n, so 792 times 10k plus 9. And when you multiply that out, we get 7920k plus 7128. And then now we'll look at the tens digit for n. And that looks like this 2 times k plus this 2. And that's got to equal, as before, this 4. Okay, so let's see what k can be for that to match up. K is most likely 1 or 6. Those are the only values that would work. Okay, if that's the case, that means k is going to be 1 or 6, and then anything that has 1 or 6 as its last digit. So 11, 16, 21, 26, and so on, right? So that means if I plug those values of k into that formula, n would be 19, 69, 119, 169, ... and it just keeps going 1119, 1169, and then the very last one, 1219, because we cannot exceed that range. So now we have to count all these. We've got our n's. We have to count this and we count that. When you count this, it's 25. When you count this, it's 25. So the total is 50. So there's 50 values that would give me a number of that form, which would equal a number like that. So therefore, number 24, the answer is E. In the diagram, PR and QS intersected V, and also W is on PV. U is on PS, and T is on PQ, and Q is on Q and ST passing through W for some real number X. If the areas of PUW are 4x plus 4, SUW is 2x plus 20, SVW is 5x plus 20, SVR is 5x plus 11, QVR is 8x plus 32, and QVW is 8x plus 50. What is the area of PTW? Before I begin this question, I'd like to give a little bit of a primer to illustrate some very important fact. And once you have that fact, it will make a lot more sense as to what the question is all about. So let's say we have a triangle, and that triangle has a base, and that base is in some ratio. It doesn't really matter, but let's just say it's in some ratio. We'll call this A, we'll call this B, and we'll call this C. Now I said to you, figure out what is the ratio of the area of this to the area of that. Okay. The first thing I need to do is draw an altitude. So I'll draw an altitude that's perpendicular to the base, and we'll call that height. So the area of AB, and we'll call this D, I guess, ABD, over the area of BCD. First, let's do it the long way, 1/2 base times height. So the top would be 1/2 base, which is AB, times height. The bottom is 1/2 base, which is BC, times height. It has the same height. And if you notice, the heights and the halves cancel, so you just have AB over BC. So in any kind of situation like that, all we really need to do to figure out the ratio of the areas of the triangles is look at the ratio of the bases, AB over BC. And that's it. If we're told the ratios, like if I was told that this AB is equal to 2 and this BC is equal to 1, then it becomes even easier, 2 over 1. So that is the primer I wanted you to learn about. So now let's tackle this guy, and of course I'm going to blow it up a little bit. Alright, here we go. Let's put it in the diagram, 4x plus 4, so 4x plus 4, and then 2x plus 20 is this guy here, 2x plus 20, and then 5x plus 20 is this guy, 5x plus 20, and then 5x plus 11 goes here, and then 8x plus 32 is here, and then there's one more, right? 8x plus 50. Okay, we're not told anything about that. We're not told anything about that. So I'll just call them something. I'll call this one M, and I'll call this one N. So this question is essentially telling me to find PTW, which would be find N. This is my task in the question. All right, here we go. And just like the primer, this triangle over that triangle is equivalent to the bases, QV over VS. So when you add it up, what do we get? Well, before I even include M and N, I think it's just easier to just include these ones since we already have. So I'll just do it with that. So QVW over this 5x plus 20, which is SVW, is going to be the same as QV over VS, right? Just like the primer. So QVW over SVW is the same as QV over VS. But QV over VS is also applicable to these guys down here. They're just upside down. And those triangles are QVR and 5x plus 11, which is represented as SVR, right? Okay, So now we can use this and this to make an equation. So that will be 8x plus 50 over 5x plus 20 is equal to QVR, which is 8x plus 32 over SVR, which is 5x plus 11. And then cross multiply, and when we do, we get 40x squared plus 88x plus 550x plus plus 250x plus 550. And then the other side is going to be 40x squared plus 160x plus 160x plus 640. And when you do that math, you get 338x plus 550 is equal to 320x plus 640. So that means 18x is equal to 90, and therefore x is equal to 5. Great, x is equal to 5. So now, all of these we can figure out in terms of numerical values. This is going to be 24. This is going to be 30. This is 45. This is 36. This is 72. And this is 90. Great. Okay. So far so good. Now let's move on to the next thing, which is involving the M's and N's. All right. Well, I think it would be very helpful if I actually knew some numbers. If I knew some numbers, that would really help me out. But do I? And the answer is sure. Why not? QV over VS, we can easily get a number for it. It would be 90 over 45, right? We already have the equation. QVW, we just figured out, was 90. And SVW, we just figured out was 45. So QV over VS looks like 2 to 1. There we go. This is 2 and this is 1. So I'll just write that here, QV over VS. So that's a very important finding. And now we can use that to figure out some very important details. So that basically means that this triangle over this triangle would be 2 to 1 in its ratio because it's equal to QVS. So PQV, that big one, over PVS is the same as QV over VS, which is 2 to 1. So PVQ, it looks like M plus N plus 90. And then PVS is 24 plus 30 plus 45, and that's 2 to 1. All right, that's pretty good finding. And that looks like M plus N plus 90 is going to be, if I cross multiply, 24 plus 30 plus 45 is 99, times 2 would be 198. So that means M is going to be equal to 108 minus N. All right, great. And I think we have just one more step to go and we'll get this. And that final step, I think, is to just look at the ratio. But in a slightly different way. We're looking at it from that angle being the base, that this is the base now. This over that is the equivalent of QT over PT. But we can also write this over that is QT over PT. So I think all I need to do is just use this fact in that diagram. So M is equal to 108 minus N, and this diagram should be sufficient. So M is equal to 108 minus N. Okay, now let's figure this out. M over N is the same as the bases QT over TP. But I can also use the big triangles, which would be TSQ over PST. And there you go. That should be enough for us to figure out M and N. And our goal is, of course, to figure out N. Okay, here we go. So since I'm interested in just an n, I'm going to use m is equal to 108 minus n over n. And then this part here, I can just get from the diagram TSQ, that's going to be m plus 90 plus 45. And PST from the diagram is n plus 24 plus 30. Okay, so 108 minus n over n, and the m, of course, I'm just going to substitute that 108 minus n plus 135, and this is n plus 54. All right, cross multiply now, and when I do, I get 108 minus n times n plus 54, and this is n times 243 minus n. And then this will become 108n plus 5832 minus n squared minus 54n. On the other side, 243n minus n squared. The n minus n squareds cancel, so that's great. I don't have to worry about any quadratic. And if I collect like terms, I'll get 189n. And then finally, n is 5832 divided by 189. When you do that, you get about 30.8. All right, 30.8. That was what I used to represent PTW, and therefore its value is 30.8, and that is closest to 31. Number 25, the answer is E.